So today we're doing snow boots from 2018 February Silver. And yeah, so we'll just go over the problem statement. So we have these 10 tiles, and each tile is covered in some number of feet of snow. And we're going to start at tile 1 and try to reach tile N. And basically, Farmer John is doing this by like wearing these boots. So he has B pairs of boots, and for each of them we have S and D, which tell us how deep the boots can step in, and also how many units forward that it'll allow Farmer John to walk. And then we know that we're basically going through the boots from top to bottom. And if he doesn't want to use a boot, then he's just going to discard it. And every time he finishes using a boot, he also discards it. So he changes his boots while he stands on a tile. And we know that when we're changing, the boots that he takes off and the ones that he puts on both have to be able to step on the F for that tile. And yeah, so the problem that we're asked, or the question is like, what is the minimum number of boots that we have to discard? And in this case, what discarding means is basically just how many we've used, or like how many boots that we've gone through, whether or not we actually use them to step on a tile. So we can discard boots like in intermediate stages without actually using them. You'll see how this is like relevant later, but yeah, we have the input, and N and B are relatively small. They only go up to 250, and then also sample input and output. So yeah, we're gonna start. Oops. For this problem, the way that we go about kind of figuring out like what algorithm or strategy is going to help is we know that we're going to go from one place to the other, so tile 1 to tile N. And also we have like different choices for where or how we travel. And another thing that we know is that the number of states is set. So state in this case is like kind of where we are. And the states for this problem is going to be a combination of like which location or which tile we're on, and also the boot that we are currently on. So if we have like boot 1 through N, we might have used 1 and then discarded 2 and then discarded 3 and used 4. And that means that we're currently on boot 4, even though we didn't actually use 2 and 3. So like the state is which tile we are on and also which boot that we've gotten up to out of the N. Or sorry, not N, it's B, out of the B boots. Okay, so yeah, we know that the number of states is just going to be any location. There's N tiles, and then any boot, which is B boots. So we're gonna have n times b states at most that are reachable. And since this is constant, we know that it can't take like infinite time or anything if we just go to all of them and see what happens. So that's actually what we do for this problem. And because n and b are relatively small, we're allowed to go to all of these states and like find out how that affects our answer for each of them without running out of time. So we're going to use a DFS, or basically it's recursive. But yeah, DFS is depth first search, depth. And basically what happens is if we have a graph with like a bunch of different nodes, and this is a tree, but it doesn't really have to be a tree. But yeah, we can go to all of these nodes and they're like connected. So in this case, like these nodes would be the different states. And what we're doing in a DFS is recursively going through each possible path to a leaf. And these are the leaves. Yeah, so if we take like a path from this starting point and then go here and then go here, that's one possible thing. And as we're going along, we're going to track some value or like update some value or something, which is going to allow us to get our answer. And then after we've gotten to this like last part of our path, we're going to backtrack. So instead of looking at this path, now we're going to look at, we're still here, this path. And then we have this like tracked value. We can update some stuff if we need to. Then we backtrack again and then go to this node. And then same thing happens. There's no more children left for this guy to go to. So we're going to backtrack all the way just to this top vertex and then go down, down, and then we can either go here or here. Basically, it's going to backtrack up and then to the right one. Yeah, so hopefully that makes sense. But this is what we're going to use to solve the problem. So we know that at any point or any state that we're in, we are allowed to either use the current boot to like step to a different valid tile. And basically we know that like DI for every boot is going to be the number of steps forward that Farmer John can go in this boot. So what this means is that we can go like 1 step forward, 2 steps forward, all the way up to DI steps forward. We have like this many number of choices as long as it, you know, doesn't go past the nth tile. So these are choices that we can make. And another thing we can do is we can also discard this current boot that we're on. And in general, we can discard some number of boots starting from our current boot. And then basically the next time we DFS, it's going to be with a different boot. So at any point, we are tracking the current tile and the current boot. So this thing is advancing the number of, or the tile that we're on, and this thing is advancing the number of boots or the current boot that we've used. Okay, so yeah, since I anticipated that this problem wasn't going to take that long, I'll just go through a little bit of the code and then that'll be it. So DFS is recursive, unlike BFS, but they can accomplish the same things. But anyway, we have a function, and as we said, we're keeping track of the number of tiles and the number of boots we've used. So in this function, first of all, if we've already gotten to the end, so the end in this case is going to be once we've gotten to tile n-1 or tile n, depending on like how you index the t's, the tiles. So probably t is n-1. Basically, if we're at the last tile, then we're done with like this specific path that we can take. And we're going to update our answer. So let's say this is our answer variable. We're going to update it by saying the answer is equal to the minimum of itself, so what it is now, and the number b. So b is how many, or like which boot we're on, but it's also how many boots that we've discarded to get to the n-1th position. Because we're discarding everything that we've used or we haven't used, but we're skipping over. So this is why that thing I was talking about before was relevant. So we're just going to take the minimum of answer and b, and then that's our new answer. And then if we're not at the end, also if we're ending, we can return so that we're just done with this whole thing. Yeah, if we're not at the end, we're going to loop through the different positions or locations, tiles that we can get to, and then also loop through the possibilities for the next boot. So because there's probably a lot of variables, I'm just gonna say loop through positions that we can go to. So the positions have to be less than n if we're zero indexing them. And also we can only advance t by at most db, because we're using boot b. db is the distance or the maximum distance that this boot can go to. So you can just use a for loop for this. And then for each one of these, we're going to call the DFS again because we're at a new state, and we're going to basically do the same thing over and over until we get to tile n-1. So we're going to call DFS on the new tile. So it would be t plus something less than or equal to db, and then we're still on the same boot. And then for looping through the different boots that we can go to or that we can use, you can pretty much go to any boot you want to. So that means that we're going to just go from b plus 1 to b. Yeah, or b minus 1, depending on whether or not you one index it. Yeah, I'm going to say b minus 1. Okay, so we're going to go from any boot b plus 1 to big B, which is the total number of boots. And we can discard everything in the middle and then DFS again from that with the same tile, but new boot. So this is the basic code. There's one thing missing though, and that is we still have to account for the fact that when we're doing this, the boot that we're changing into has to be like able to withstand whatever the new like the new number of feet on the tile is, and also the new boot has to withstand the current tile's number of feet. So before we DFS for both of these, we're going to say if the boot, whether it's the current one or the new one, can withstand the tile's feet. And this is whether the tile is new or we're still staying at this tile. So yeah, sorry that was a little bit backwards. I just forgot about it. But yeah, you can kind of see like the symmetry in this problem where we're either going to update the tile that we're on or update the boot that we're on, and like the different scenarios are kind of reflections of each other. Yeah, so this problem is not too bad once you realize like we should go through all the states and update our answer for each of them once we're done. Yeah, so that's it.